guys, this is test 64 game 1. This is the parking spaces game. It's an ordering game. We know this because the employees are assigned to spaces 1 through 6, and the rules are referring to things being higher numbered spaces than others. So we're basically putting them in order from 1 to 6. Now I've laid out some things here. I'm going to explain all of those. We've got that y is a higher numbered space than t, so y is going to be to the right of t since the numbers go from 1 to 6. With the higher numbers on the right. So remember, when they say y is higher than t, they actually mean it's t before y. Next, they say that x is higher than s, meaning s is before x. S is to the left of x. Next, r is higher than y, giving us the general order t, y, r. So I linked those things together. Now, there are a few inferences we can make based on this. If s is before x, then x cannot be 1 and s cannot be 6, because if s was on 6, x could not go after it, and if x was on 1, s could not go before it. We also have a bunch of rules we could put down regarding t, y, and r, but it would just become too many restrictions to map. I'm going to have another way to indicate that in a bit, so hang on to that for a second. The final rule tells us that r is assigned to spaces 1, 2, 3, or 4, so I simply write down that r cannot be on 5 or 6. It's a little bit more concise that way. Now, this is a very bare-bones diagram, and I haven't really done a lot with the TYR thing, which is actually pretty significant because TYR is occurring in that order, and it has to occur within the first 4 spaces because R can't be on 5 or 6. So TYR is going to go within the first 4 in some combination. Now, we know that S has to go before X, and we know that S cannot go on 6. So I actually use this restriction, believe it or not, to make 2 different main diagrams based upon the placement of S. Because if S were to go on 5, then X would have to go on 6, and we'd have TYR along with V occurring in spaces 1, 2, 3, and 4. So it would actually become very limited. I'll show you what I mean. So this is the diagram where S is on 5, just to show it to you. If S is on 5, we're going to have X on 6, and then we're going to have T before Y before R occurring within the first 4 as well as V. All within the first 4 spaces here. So it could be V on 1 and then TYR after it, or V between T and Y, V between Y and R, or V between R and S. Either way, very limited possibilities. Now, if S were not on 5 and it were not on 6, therefore it would have to be in the first 4 spaces somewhere, and V would be forced later interchangeable with X on 5 and 6. So here in the alternate diagram, we have S not on 5, meaning, of course, since S is not ever on 6 either, S has to be somewhere within 1 to 4, kind of playing the same role V was playing on top. S could be before T, between T and Y, between Y and R, or between R and then whatever is on slot 5. So V and X essentially become interchangeable on slots 5 and 6. We can't lock them down to particular places. I mean, V, there's no rules about V at all, and X simply has to go after S. But because R can't go on 5 or 6, the TYR ordering is happening within the first 4 slots. So these right here are our 2 main possibilities for the game, and we'll be using these 2 diagrams over the course of the game. So question number 1 is a typical orientation question. Just take one rule or inference at a time and apply it to all 5 choices, looking for violations. So I think the TYR ordering is a good thing to start with because it's really the combination of the first and third rules. So running through the choices, we find that choice A violates this, having YRT rather than TYR. That's bad, so for that reason, A is eliminated. Also, choice D can be eliminated because it has TRY rather than TYR. So we got rid of 2 using that. We also know that S has to go before X, so using that, we get to eliminate choice C, where we have X before S. That's unacceptable, so C is gone. We're down to B and A, and finally we can use the fact that R cannot be on either 5 or 6. So using that, we find that choice B violates it, having R on 5, so for that reason B is gone, leaving E is our answer for number 1. Next, number 2, if T was assigned to a higher numbered space than S, meaning S was before T, of course that could never happen in the top diagram. We're only going to use the bottom diagram here, and we're going to have to put S on 1, T on 2, Y on 3, and R on 4, because that's the only way that we could actually have S before T. So everything becomes extremely defined. The only ambiguity that remains is whether we have V on 5, X on 6, or X on 5, V on 6, and 1 through 4 are specified as S on 1, T on 2, Y on 3, R on 4. So what could be true? Could Y be on 2? No, T's there, Y's on 3. Could V be on 5? Yes, it could. V could be on 5 or 6. So B is our answer for number 2. I will look at the rest though. T on 3, of course, doesn't work. T's on 2. That's gone. S on 2 doesn't work because S is on 1. And then looking at E, R on 3 doesn't work because R has to be on 4. So B is our answer for number 2. Next, number 3, they're asking us what would fully define the placement of the variables. So we'll just run through the choices, asking ourselves what limits it with no ambiguity at all remaining. So S on 1 wouldn't do it, as we just saw. That still left 5 and 6 undefined, whether it's V5x6 or x5v6. It wouldn't resolve that ambiguity, so for that reason, A does not fully determine it. Looking at B with Y on 2, of course, that could easily happen in either diagram, so for that reason alone, it does not define things enough, so B is gone. C with V on 3, of course, that could never happen in the bottom diagram, only on the top one, so we're only going to look at the top diagram here. And if V were on 3, I'm just going to make a little room here. If V was on 3, we would have to have R on 4, Y on 2, and T on 1. So V on 3 would be placing V between Y and R in that sequence right there, and 5 and 6 are already determined as S and X in this diagram, so no ambiguity. C is our answer for number 3. I will look at the rest though. R on 4, of course, could have happened easily in either diagram, so that's gone. And then X on 5 could have happened only in the bottom diagram. The top one would not have been relevant, but that still would not have told us where S went. S would have been able to go before T, between T and Y, between Y and R, or between R, and then, of course, between X on 5. So that would not fully determine it, so E is gone, leaving C for number 3. Next, number 4, for how many employees are we limited to only one of 2 spaces for those people? So, of course, S is not limited in that way because S could be on 5 or could be any of the first 4 in the bottom diagram. So for that reason, we can't have all of them. So I'm going to just cross off S in the top over here. Also, we know that V is rather ambiguous because V could be any of 1 through 4 looking at the top diagram, and then the bottom diagram, V could be 5 or 6. So V could actually be in any of the 6 slots, so I'm going to eliminate V as well. However, for the other variables, things are rather limited. X could be on 6 on the top diagram or on 5 or 6 in the bottom diagram, so for that reason, X is limited to only one of 2 slots, 5 or 6. Then the other guys, T, Y, and R, they overall as a sequence it ranges from 1 to 4, but they really only have limited to 2. They only have possibilities limited to 2 slots for those guys because let's say whether we're in the top or bottom diagram, V and S have the same role in limiting T, Y, and R. If one of V or S was on 1, T would have to go on 2. If one of V or S was later than 1, we would have to have T or T on 1 as a result, so T's only either 1 or 2. Same thing goes for Y and R. Y is always either on 2 if S is after it, or V is after it, or on 3 if S or V is before it. And then, of course, same thing goes for R. R is always either on 3 or 4, depending on whether V or S goes before it or after it. So X, T, Y, and R are 4 variables, and they're the only 4 that are limited to 2 slots. So for that reason, D, 4, is our answer to number 4. Next, number 5, if Y was a higher numbered space than S, meaning that S was before Y. So of course, that's not going to happen in the top diagram where S is on 5. It's going to happen only in the bottom diagram. So it's going to give us a general sequence with S on 1 or 2 interchangeable with T, making a sequence kind of like this. T and S are both before Y. Then we have R following them. So R is going to be definitely on 4, Y will be on 3, and then T and S are interchangeable on 1 and 2 in some order. We don't know which one. V or X is on 5, and then X or V is on 6. So what could be true? Could T be on 1? Yes, T could be 1 or 2. So A is our answer for 5. I will look at the rest though. Y on 2 doesn't work because as you see, Y is on 3, so that's gone. Looking at R on 3, no, R is on 4. Looking at S on 3, no, S is either 1 or 2. We don't know which one, but it's not ever 3. And then V on 4 is impossible because V is on 5 or 6. So A is our answer to 5. Finally, number 6, if R was on 3, what must be true? So R on 3, of course, could happen in either diagram. If R is on 3 in the top diagram, V is forced to come after it on 4, since T and Y have to come before it, in this case on 1 and 2. In the bottom diagram here, if R is on 3, same thing happens with S. S has to go on 4, and then T and Y are on 1 and 2 as a result. So both possibilities are relevant here. We have TYRV or TYRS, and then 5 and 6 are always constants anyway. So what must be true? S on 4, it happens in the bottom but not in the top. So for that reason, A is eliminated. For B, T on 2, no T specifically on 1, that's impossible, so that's gone. Looking at V on 5, V's on 4 in the top and could be on 5 in the bottom, but could also be on 6, so C's gone. X on 6 happens on top for certain, but on bottom, X could also be 5, so finally E by elimination. And if you look at E, Y on 2, of course, is happening in both. Of course, also T on 1 is happening in both, but they didn't ask about that. So E is our answer to number 6.